Welcome to section 7.5, Object Interaction and Encapsulation. This lesson is where object-oriented programming starts to really take shape. It's not just about creating classes anymore. It's about how they work together and how to control that interaction carefully. Here's what we'll dive into: how objects interact with each other, how to use private to protect class variables, why getters are used to access data, and why setters are used to modify data in a safe way. We first touched on object interaction way back in session 2. But now it is time to really explore what it looks like in code. There's no fixed sequence for how objects must interact, so it's up to you as a designer to plan that wisely. So what's object interaction? Whenever one object has a reference to another, that's it knows where it lives in memory, it can interact with it. That means reading or changing its fields or calling its methods. The main method often instantiates every object and holds all the references. That makes it the central place for interaction. But is that always ideal? Let's say we've got a program with 3 classes: prisoner, cell, and guard. In main, we might create one of each and assign values. Prisoner P01, assign new prisoner. Cell C01, assign new cell. Guard G01, assign new guard. From here, the main method could directly manage everything. But now, the main method is handling all the interactions. It knows everything. It controls everything. That works for small programs, but for larger ones, it becomes messy really fast. Sometimes you want objects to interact with each other. For that to happen, one object needs to know a reference to another, either as a field or by receiving it as a method parameter. In exercise 1 part 1, let's try that. Continue working on your prison test project. Create a cell class with a string name, a boolean is open, and 2 argument constructor. Then update the prisoner class to include a cell field. In display method, print the prisoner's name and their cell name. In exercise 1 part 2, add an open door method to the prisoner class. This method should check if the door is open, toggle it, meaning open it if closed, close it if open, and print what happened. Now in main, create a prisoner and a cell, link them, call display, then call open door a few times. Except there's a problem. The guards are freaking out. Why? Because prisoners can open their own cell doors. Not exactly secure software, right? So now we have to ask these important questions. Which objects should really have access to each other? Should prisoner know about cell? Should cell know about prisoner? Should neither? The goal here is separation of responsibility, also known as encapsulation. Think about this. Cells are meant to open and close, sure, but who should be allowed to trigger that behavior? Not the prisoner, of course, but definitely the guard. You've actually been thinking about these things before. If you've done Java Puzzle Ball, you've already practiced how to distribute responsibilities wisely between object types. Now we introduce encapsulation, a technique for protecting your data and controlling access. With encapsulation, you limit visibility of fields and methods. You decide exactly how and when objects can interact, and you avoid unwanted interference. We do this using access modifiers, the public and private keywords. Let's look at cell class. Both fields are public, which is not ideal. Quick rundown on access levels. Public, visible from anywhere. This is the least secure one. No modifier. Package private, only visible within same package. Private, only visible inside the class. Most secure and most recommended for fields. In exercise 2, go back to your cell class. Make both fields private. Save the file. What happens? Your IDE might start complaining. And that's a good thing. It's helping you spot unsafe code. With those fields private, even the main method can't access them. And thankfully, neither can a prisoner. Encapsulation is now enforcing rules like no prisoner shall open a cell door. But now you've got a new problem. The prisoner can't even read their cell name. That's not ideal either. We need a way to safely access the private data. The solution is getter methods. A getter, also known as accessor, is public, takes no arguments, returns the value of a field. For instance, public string getName, return name. Now, other classes can read name but cannot change it directly. Do the same for isOpen. Public boolean get isOpen, return isOpen. Now your prisoner's display method can include the cell name again, safely. But what about cases where we do want to change a field safely again? Let's say a guard needs to open a cell. You don't want them to do this directly, like cell.isOpen assign true. That's too exposed. Instead, we use a setter, also known as mutator. Setters are public. They accept a value as a parameter. They have a void return type and set a field with conditions if necessary. Public void set is open, it takes a parameter, boolean is open, then assigns this dot is open, assign is open. But be careful here. You don't want just anyone calling that method. This is where designing your setters carefully come into play. You can require things like a security code, a permission check, or restrict access to trusted classes only. Exercise 3 part 1. Update cell so that it has getter methods for name and isOpen. It has a private field for a security code set in constructor. It has a setter for isOpen that accepts the code, checks if it is correct, prints an open-close message based on the result. In exercise 3 part 2, in the prisoner class, remove the open door method. Okay. Modify display to include the cell name using a getter. In main method, instantiate cell and prisoner. Call the cell secure setter with both correct and incorrect codes. Try it out. It is surprisingly satisfying when it works. Remember the spiral model of development. At this point, main method is your test lab. It's simulating real-world actions. When you call baba.openDoor, you're pretending the prisoner controls the door. When you call cell.setIsOpen1234, you're simulating someone entering a security code. Eventually, a guard class should handle that, but for now, main method is playing that role. In exercise 4, fully encapsulate your prisoner class. Make all fields private, add getters and setters for each one. Yeah, it's a bit tedious, but it's a good practice. And yes, that probably wasn't the most thrilling exercise. Some developers love the control of handwriting encapsulation. Others, they just let their IDE do the work. That's totally valid. If you are using NetBeans, here's the trick. Highlight the fields you want to encapsulate, right-click, then refactor, then encapsulate fields. Then tweak the settings to your liking, click refactor, and boom, NetBeans auto-generates your getters and setters. This saves time and avoids typos. To wrap up, encapsulation helps limit what other classes can see or change. Fields should usually be private. Getters provide real access. Setters provide controlled write access. And yes, a little planning goes a long way in designing which class can do what. You've now got the full picture: how objects interact, how to protect your fields, how to expose just enough using accessors and mutators, and how to let some objects interact while keeping others out. That's real object-oriented design in action.